Good morning. This is Robert Smith with Channel 7 News. We interrupt your regularly scheduled programming for this important news bulletin. There has been a possible chemical weapons attack in Mr. Kemmer's chemistry class in Hampton High School. We are here with a chemical weapons expert, Ryan Diable, to find out more about the developing situation. Ryan, thanks for taking time to talk with us.
Hi, Robert. Happy to join you. I hope I can help. Do the authorities know if any of the victims have been examined?
From some early reports, some of the victims were experiencing extreme salivation, weakness in muscles, and difficulty breathing. Does this help narrow down what might be happening?
Yes, because these are all symptoms that can be associated with the anticholinesterase class of nerve agents.
Can you tell us a little more about these nerve agents?
The G-class nerve agents were invented first by Germans in the 1930s. The V-class nerve agents were developed later by the British in 1952, so there is a 16-year difference between the G-class agents and the V-class agents. The G and V-class nerve agents are generally from a class of chemicals known as organophosphates. To clarify, an organophosphate is just a molecule that originates from phosphoric acid and has essential phosphorus. Organophosphates can be found in pesticides.
From our field reporter, we are now hearing that some of the victims are describing a faint fruity odor. Does that help you narrow down the possibilities?
It does, since most of the nerve agents are odorless. Tabun is known for its faint fruity odor, so I would worry that that is what we are dealing with here. In fact, in 1988, during the final days of the Iran-Iraq War, Saddam Hussein's army attacked the Kurdish province near the Iranian border with chemical gases, including Tabun.
What do we know about Tabun?
Tabun, which has the formula shown here, was first synthesized in 1936 by German scientist Gerhard Schrader with the intent of it being an effective pesticide. When it was used as a pesticide, it was found to be deadly to humans and could not be used on food or anywhere near humans. This led to the discovery of how Tabun could be used as a chemical weapon in warfare, and so Tabun is actually the first nerve agent ever made.
So what makes you so worried if it was Tabun that was involved in today's attack, and how can Tabun harm people?
So, the most likely way that nerve agents are used is if it is aerosolized into the air. Also, Tabun in liquid form can be absorbed through the skin. As little as 4 grams of Tabun on the skin can be lethal in as little as 15 to 20 minutes.
So how would it get into the air, and if it is in the air, how long does it last?
So to answer your first question, Tabun starts evaporating rapidly from its liquid form at room temperature. So this makes it very effective at becoming airborne. To answer your second question, when Tabun evaporates into a gas, as it settles on surfaces, it can stay in the environment for 1 to 2 days under normal weather conditions. Liquid droplets or even vapor may persist in a victim's clothes after minutes to hours of exposure, which may lead to cross-contamination of others.
So, if you have a gas mask on and cover your skin, you are safe?
Well, that is true for most of the organophosphate nerve agents, but Tabun is one of the few nerve agents that is water-soluble, so can infiltrate water and food supplies. If that is what happened here, we could see the effects of this spread outside of the affected area.
How easy is it to get into water supplies, and how long does it last in water?
Of all organophosphates, Tabun has the highest solubility in water, which makes it particularly deadly because of how easy it can get into the water supply. Tabun has the longest half-life in water out of the nerve agents and can last for 8 hours in fresh water and up to 4.5 hours in salt water. Tabun can also persist in snow for approximately 2 weeks.
That's terrible. You can die from drinking tap water?
Actually, you don't even need to drink it. Just touching water contaminated by Tabun can make you sick or kill you.
Wow, that is scary. Tabun can be spread in the air or by introducing it into the water supply and has the longest half-life in water of the nerve agents. So when exposed to Tabun, the nerves using acetylcholine become overstimulated?
Once the nerve agent is absorbed into the body, some of it ends up in the connections between the nerves called synapses. Once in the nerve synapse, Tabun blocks cholinesterase, which is the enzyme that breaks down acetylcholine. Since acetylcholine is the chemical that carries nerve impulses from the end of one nerve, called the axon, to the beginning of another, the dendrite, it builds up and causes overactivation of the nerves.
Does this affect all the nerves in the body?
To summarize the figure, poisoning by a nerve agent like Tabun leads to convulsions and other effects in the brain, contraction of pupils and blurred vision, profuse salivation and runny nose, heart rate and blood pressure changes, and abdominal pain. Death is caused by suffocation due to airway constriction and loss of control of respiratory muscles.
So are all nerve agents the same?
No, they all have varying levels of potency, but Tabun in particular is more irritating to the eyes at low concentrations. This makes Tabun more dangerous because without vision, it can be harder to get away from the gas.
So if you are attacked and you survive, are there longer lasting effects?
It can cause inflammation and damage to the nerves, and genotoxic effects are suggested mechanisms of delayed damages of Tabun.
Wow, that's terrifying. I can see why you are so worried that this may have involved Tabun. What do experts do for a person who has been exposed to Tabun?
First, you make sure you are protected and then remove the victim from the contaminated area. After that, give antidotes such as atropine and oximes like sodium hypochlorite to symptomatic cases. After that, you should give supportive therapy like oxygen to those who need it.
Is there any way that a person can protect themselves?
In addition to protective masks and clothing, the military has developed agents like pyrostigmine, which soldiers use if there is a concern about a nerve agent attack. Pyrostigmine reverses the effects of anticholinesterase agents' activity and is administered to military personnel at risk from exposure to nerve agents such as Tabun.
So at least there are some ways to treat or protect people from these agents, but it sounds like if this is Tabun, it is really a worst case scenario.
Yes, I would have to agree that it is the most dangerous organophosphate nerve agent. As we discussed, it has a high water solubility and longest half-life, which makes it the most dangerous agent for attacks involving water or food supply. Furthermore, its combination of volatility and higher irritability on the eyes and effect on vision makes it the worst agent for aerosolized attacks. Finally, even though there are differences in concentration that causes the toxic effect compared to other agents, the huge stockpiles of Tabun suggest that carrying out an attack with a highly lethal dose is possible.
Hold on, Ryan. We are getting an update from Hampton High School. The authorities are now reporting this might have been a false alarm. Apparently, there were some fruit pies burning in the school cafeteria ovens, and the odor made some of the workers and students sick.
Okay, Robert, I'm glad to hear that this was not a chemical weapons attack and that Tabun was not used.